Um, and let's go ahead and look at the next step. So now we have basically a drawing of the teapot. So we know that the reading in of the model actually worked, but we're of course not seeing it the way we want it to. So let's fix that and move the model so that we can see it. And so that's happening in the next stage here. Check that out. And let's have a look at what's happening now. So first, let me compile this and show you the result. So now, as you can see, the teapot has been moved and rotated so that it actually is in the center of the screen. So let's go ahead and see what we've done. We're just basically, this is again in the OpenGL member function. This time around, before we draw it, we just create a model view matrix. And in that model view matrix, we're not changing the view as of now. But right now, so we're keeping the view, so ultimately that model view matrix is just a model matrix. But we take the model and actually translate it first into the center of the word coordinate system. This is what's happening here. We're doing that, and we're going to see that when we actually look at the teapot class. So what we're basically doing is we're computing the bounding box of the teapot and then obtain the geometric center of the model, and then just undo that in terms of word coordinates and effectively translate the model into the center. And then we're going to rotate it minus 90 degrees around the x-axis, which puts it into the corresponding perspective. Remember that when you do transformations like that, we multiply our transformation matrices from the left to the vertex vectors. So meaning that the translate comes first and then the rotate comes next. And so as far as the boundary box goes, and that model view matrix then is passed to the shader in a uniform, which happens right here. So that the vertex shader has access to it. So we're going to see how that works in a second in GL setup. Let's go back and do the Teapot model real quick. We're edit some data members here for the maximum minimum extents in X, Y, and Z. Then as we read in the model, we'll just keep track of the maximum and minimum coordinates. And then the bounding box is just the extent of that. And then we'll just say, well, if I add minimum maximum together divided by 2, that's the center on that particular axis. I do this for all 3 axes, I get the geometric center of the model. And that's what's just happening here. I initialize, of course, the maximum value with the minimum possible, so that in the reading in, I can just apply the max without having to prime the loop. So that's the easiest way to obtain this stuff. So as far as the uniform goes, so we have created the model view matrix, and we need to pass it into the vertex shader as uniform. That's happening here with a set uniform value. But in order to do that, we have to actually add a location which is just an integer that we're going to actually get when we set up the program. And so that's happening here in initialize GL. So, and that basically happens here. So I get the uniform location for the name MV matrix in the shader program. This is on a per program basis, so we have to do this after the program has been linked. So we're getting this and just storing it for future reference. And then in the vertex shader, we see that we now have the uniform that is the model view matrix on top of our other two arrays for the vertices and the normals. And then this time around, we'll just multiply the incoming vertex with a model view matrix to do the transform and the transformation, and that's that. And the result is indeed that the model now is being moved to the center and is actually in the is actually rotated correctly and upright.